Hello again, Math 10 students. In this video, we're going to be going over Check Your Understanding, number 4 on page 382 in your math books. So I'll give you a second to get there. You can always pause these videos at any time. You need to go to the bathroom? No need to ask. Just pause the video and you go right ahead. All right, any volunteers to read this question? Okay, nobody. I guess I'll do it for today. All right, so Akigo is making a ribbon shirt. What is a ribbon shirt? I don't know. All right, she has 60 centimeters of ribbon. Okay, remember what I like to do when we're doing a question. I write down whatever they tell me. So 60 centimeters of ribbon, great. That she will cut into 5 pieces. Okay, 5 pieces with 2 different lengths. 2 pieces have the same length. 2 are the same, okay. And the remaining 3 pieces also have equal lengths. Okay, great. So this says generate some data for this relation showing possible lengths of the pieces. Okay, so you could do some guesswork here if you wanted to. We know that it needs to equal to 60, and there's going to be 5 pieces. 2 will be the same, and 3 will be the same. So for example, 2 pieces of ribbon are the same, 3 are the same. Okay, so you're trying to figure out, and we know this whole thing has to equal up to 60. All right, so you could do some guesswork, some trial and error. You could say, okay, I could have 3 of these equal, you could pick a number and try it. You know, you could say 2. Let's say 2, 2, and 2. 2, 2, 2. That's 6. It means I have 54 left, and they have to be equal. So half of 54, 27, 27. Let's see if that works. 27, 27, 54, 56, 58, 60. So that could be one possible one, okay? You could pick your x and y to be either one. What I mean by that is, I could put this as my x's or this. It really doesn't matter. Your graph might just look a little different, but you're just picking one. So why don't we say that our x will be the piece of 3. Okay, so let's say that length could be 2. For the y, it could be 27. Okay, so remember our x was when the piece of 3, the 3 equal ones, and our y was the 2. Okay, so that's one way. You could kind of keep trying a few different things. You could try, you know, you could get into decimals if you wanted to, but I'd like to pick whole numbers. The other way, and the book doesn't really go over this, but this is what I would do if I were trying to solve this. That question said that she was going to have 2 that have a different length and 3 that have the same length. Or sorry, 2 that have the same length and 3 that have the same length, and they equal 60. So you also could have kind of come up with an equation right away. The book doesn't do this, but this is what I would do. So I would have said, okay, I'm going to have 2 the same length and 3 the same length, and that equals 60. So 2 times my y plus 3 times my x is 60. You could have also said 2x plus 3y equals 60. It doesn't really matter. So you could have used this equation as well. You could put something in for x, for example, get a y out. Okay, and that would be another way that you could kind of fill in this chart. But I'll just do another point. Let's see. Let's say if we made these each 4. Okay, that would be 12. 12 minus 60 would get me down to 48. 48 divided into 2 is 24. So these could be 24. So there's another one, 4, 24. From there you can kind of almost see a pattern. This is linear. You can see this is going up by 2. This is going down by 3. So this next one would be like this, and so on and so on. So there's lots of points there we have, okay? So that says generate some data for this relation. Here's some data, okay? We came up with some data, great. B says graph this, okay? So I'm just gonna erase this. And like I said, at any time, if this is too fast, you can pause it or you can stop, okay? So I guess I'll just leave. I'll use these couple points, whatever. Okay, let's graph them. All right, so let's label our axes. And we had said that an x could be 2, 4. Again, this is going to be a rough graph that I'm doing, but, oh, sorry, 2, 27. 2, 27. 4, 24. It'll be 6, whatever. So you can see it's going like this. Okay, something like that. And this would go on for a bit. It wouldn't go, I shouldn't really put arrows because you wouldn't have negative parts of ribbon. Okay, so it really would just go down to this and this. Okay. Now, next it says, write an equation for the relation in general form. Okay, so we need to form an equation in general form. I'm just thinking about this graph too. She said she had 5 pieces, so it could never really hit there. So I'm just going to put an open circle because it would not include 0. Okay, so the next part said, write an equation for the relation in general form. So just to review, we know general form looks like this. AX plus BY plus C equals 0. Okay, so we could do a couple things here to find this equation. Why don't we use our slope point form, okay, and then we could change it into this general form. That might be good. Another sneak way you could do this is, remember I told you this equation earlier? This would be super quick. Watch this. Minus 6 equals 0. That would be a super quick way. That is actually our answer. But I am going to show you the way the book does it as well, if you weren't able to come up with this equation yourself. You could, though, just bring that 60 over, be minus 60 here, and that would be our general form. So let's see if we can do that, though, a little bit longer way. Okay. Let me just erase this. Okay. So let's use our slope point form, and I am going to use the point 227. That was a point that we had, okay? So let's find our slope for, let's find our slope first. We know it's the change in y over the change in x. So let's do our y. 27 minus 24 over 2 minus 4. That would be 3 over negative 2. Okay, so now we have our slope. Negative 3 over 2. Okay, negative 3 over 2. That is our slope. And again, we did that by doing our y minus y, x minus x. I could have also gone in this direction. Just make sure you're being consistent with how you're doing your slope. Okay, now let's use our slope point form. Let's put that in. So our slope point form is y minus y1 equals m bracket x minus x1. Now, you can pick any point you want. I'm going to pick, I think I picked this one, okay? But you can pick any point you want. You're still going to have the same answer. All right, so I'm going to put in y minus 27 equals slope. We got our slope already. Negative 3 over 2, bracket x minus 2. Okay, again, you could use any point you want. So, but this asks me for general form. So I need to get this into general form. So let's go ahead and do that. First things, there's different orders you can do this in, but I do want to get rid of this fraction because I know I cannot have fractions in my general form. So because there's a 2 on the bottom here, I'm going to multiply everything, both sides, by 2. All right, so I'll show you that. 2. Okay. And again, 2, and I'm multiplying the whole side. Okay, by 2. So, using your distributive property, 2 times y is 2y. 2 times negative 27 is negative 54. Over here, because these are all being multiplied together, this 2 and this 2 will cancel out. So this is actually, that's why we did this, right? We wanted to get rid of that 2. okay? I don't use a distributive property here because these are all being multiplied by one another. You only use that when it's like subtracting inside or adding, okay? So those cancel out and I'm left with -3 bracket x minus 2. Beautiful, that is a lot easier to work with. Let's simplify this. So I'm gonna keep my 2y minus 54 on this side. -3 times x is -3x. -3 times -2, negative times negative is a positive. Okay, we got that, plus 6. All right, we're looking good. Now, general form, as we know, ax plus by plus c equals 0. We need everything together. There's no party when you're by yourself, so let's bring everything on the same side, and let's make sure that this first one is not negative. Okay, so let's bring everything over to the left side, and then we can rearrange it later if we want. So 2y minus 54, we'll keep that how it is. When we bring this over to the other side, this becomes a positive 3x, this becomes a, negative 6, good. Equals 0, right? Because we brought them over. The way we did that was, because what we're doing really is adding 3x to both sides, minusing 6 from both sides, right? That's what we're really doing. Okay, let's simplify this and we'll be done. Let's put our x first, and look, I'm happy because there's no negative here, okay? Then we're gonna put our y, 2y. Let's combine our like terms. -54 minus 6 is, minus 60 equals 0. Woohoo! Oh, happy day, there's our answer. We have 3x plus 2y minus 60 equals 0. Let's go back and see if that was the same as what we got here. Well, I didn't rearrange this, but yes, 3x plus 2y minus 60 is 0. General form, there's our answer. Boom. Excellent. Good work, people. All right, now for D, it says, can each of 2 pieces be 18 centimeters long and each of 3 pieces be 3 centimeters long? All right, let's try that. How would we do that? We're gonna plug that in to our general form, aren't we? All right, I'm gonna erase this. If it can be, the left side and the right side will be equal when we plug those values into our equation. So let's do that, okay? So I'll start with my equation that we got, 3x plus 2y minus 60 equals 0. And they said, could the pieces of 3 be 3? Okay, and which pieces were the pieces of 3? Yep, this, right, because we have 3 times that. 3, so I'm going to put in the 3 there, and the piece of 2, could it be 18? So I'm going to put that in there. So if yes, if this could be, all right, if you could have 3, 18 like this, then we'll see that the left side will equal the right side, and it'll be wonderful. Let's try. 3 times 3 is 9. 2 times 18 is 36. Okay, let's combine our like terms here. So 9 plus 36 is 45. 45 minus 60 is minus 15. Oh no, is minus 15 equal to 0? Absolutely not. So no. No. They could not have 3 pieces of 3 and 2 pieces of 18. That does not equal, that doesn't work, right? Okay, great. Let's go to our next one they asked us then. Erase that. Okay, next they say, could I have had the 3 of 18, I believe, yeah, and 2 of 3. So again, I could start with my 3x plus 2y minus 60 equals 0. And let's see, 3 times 18 plus 2 times 3 minus 60 equals 0. You could also, I mean, we're using our general form equation that we got. You could have also just done this. You could have tried it like, okay, 18 plus 18 plus 18 plus 3 plus 3, does that equal 60? It's the same thing, right? That's the same thing as what we're doing, but I'll just use this form. 3 times 18 is 54, plus 2 times 3 is 6, minus 60. 54 and 6, 60, minus 60. Oh, happy day. This is equal. So yes, they could have 3 pieces that are 18 centimeters or whatever they said, and 2 that are 3. And again, you could have also just done this, 18 times 3 plus 2 times the 3, or 2, sorry. And you would come up with the same. I did that wrong. Forget that. Anyway, you could also use the original equation. Okay, so that one is right. So there you have it. That is our Check Your Understanding number 4. I did assign questions on the page, so you can go back and look at those. So what we'll do is, once you've tried some of your questions from this beautiful unit, you can ask me to go over any. I'm happy to do a video. I'm happy to do a one-on-one call with people using Google Hangouts or Zoom or Skype or whatever you have, or WhatsApp. So into technology. So for the next 2, today is Wednesday. So for Thursday and Friday, we'll also be doing some review questions, and I'll be sure to go over a couple of those as well. And then next week, I will be giving you, probably it'll be more like an assignment than a test. I'll give you a day to do it. You'll be able to use your book, because it's a little harder to do tests in this format. But I'll give you more details on that as I have them. I'll work on that over the weekend. So, all right, wonderful. I hope you found this useful. If you don't find videos useful and you like working just from the book and going over the book is excellent. That's great too. No pressure to watch what I'm doing here. I'll make sure that I'm always doing things online, saying the questions and things like that. So you're welcome to do that as well. No pressure. All right, have a great day. Happy mathing.